In today's era, we have been already surrounded by technologies and computers. This is because we are now on the fifth era, or also known as artificial intelligence era. Computers are basically around us. Malls, school, churches, and even in our homes, we can see computers. The discovery of computer was one of the greatest achievements this world had. Thanks to Charles Babbage for discovering this helpful machine. Computers helps us a lot in our daily lives. It may be for work or for school. Speaking of computers, there is a term for computer components that are connected together, and this is called computer architecture. Computer architecture is concerned with the way hardware components are connected together to form a computer system. It acts as the interface between hardware and software, and computer architecture helps us to understand the functionalities of a system. In today's world, there is these two famous computer architecture, namely von Neumann architecture and Harvard architecture. Von Neumann architecture was first published by John von Neumann in 1945, while Harvard architecture dates back to 1937 with implementation finished in 1944. Von Neumann consists of a single shared memory for programs and data, a single bus for memory access, an arithmetic unit, a program control unit. Its processor operates fetching and execution cycles seriously, while on the other hand, Harvard architecture has two separate memory spaces dedicated to program code and to data, respectively, two corresponding address buses and two data buses for accessing two memory spaces. Its processor offers fetching and executions in parallel.
The advantage and disadvantages of von Neumann architecture and Harvard architecture. These computer architectures also have both advantages and disadvantages. On von Neumann architecture, the advantage is it has less physical space requirement. It just handles one memory block simpler and easier to achieve and is much cheaper than Harvard architecture. The downside or the disadvantage of the von Neumann architecture is that the instruction and data memory is combined and shared between the processor and memory with one data bus and one address bus. It is important to fetch instruction and data in sequential order, known as the von Neumann bottleneck, which restricts memory access bandwidth. In microprocessors today, it is popular to split the level 1 caches into instruction and data caches to support bandwidth. Shared memory, a faulty program in memory will overwrite another program, causing it to crash. Memory leaks some faulty program to fail to release memory when completed, which can use the machine to crash due to insufficient memory. Data bus speed, the CPU is much quicker than the data bus, which means that is always idle. Von Neumann bottleneck. Fetch rates, the same data bus is shared by data and instruction, but the rate and which each must be accessed is often somewhat different. While the Harvard architecture has the advantage like data and instruction are stored separate buses, there are very few chances of corruption. Data that uses read-only mode and instructions which use read. Write mode are operated the same way. Generally, two memories would be present, one for data and another one for instruction. They have different cell sizes, making use of the resource very effectively. The bandwidth is used for memory is much predictable. Parallel access to data and instruction can be maintained. Control units get data and instructions from one memory. Thus, it simplifies the architecture of the control unit. The disadvantage of Harvard architecture is the unoccupied data memory cannot be used by instruction, and the free instruction memory cannot be used by data. Memory dedicated to each unit has to be balanced carefully. The program cannot be written by a machine on its own as it is in von Neumann architecture. There are two buses of the architecture, which in the way means that the motherboard would be more complex which in turn means that there would be two ROMs and thus tend to have very complex cuts decide. Production of computer with two buses takes more time to get manufactured and is again on the expensive side, like the control unit. Harvard architecture has more pins on its IC, therefore it is more difficult to implement. It's not being used widely, so development of it would be on the backward edge. These are the advantages and disadvantages of von Neumann and Harvard architecture. In conclusion, von Neumann is used over Harvard much of the time as it is cheaper. To implement, Harvard is used only when speed advantages outweigh the cost.
What is quantum computing and how does it work? Binary data encoding with bits containing zeros or ones, electrically interpreted as on or off states, is central to computing. Quantum computing reimagines the approach, replacing bits with qubits, as they are commonly known in classical physics, can simultaneously manifest multiple states. Quantum systems that represents data using qubits and quantum phenomena such as superposition and entanglement theoretically allow massive parallelism to be computed at unprecedented levels. The two major distinctions between quantum bits and classical bits from the machines we use today are the physical shape taken by the bits and the essence of the data stored in them, respectively. A classical computer's electrical bits can only exist in one state at a time, either 1 or 0. Subatomic particles, including individual photons or electrons, are made up of quantum bits. Since they adhere more to the laws of quantum mechanics than to classical mechanics, these subatomic particles exhibit the bizarre properties of quantum particles. For computer scientists, the most salient of these properties is superposition. This is the principle that concurrently, at least until the state is measured and collapses into a single state, a particle will exist in multiple states. The qubits of a quantum computer begin in their 1 and 0 hybrid state as the computer begins crunching through a problem initially. When the solution is sought, in order to return the solution, the qubits in superposition collapse to the proper orientation of stable ones and zeros.
Advantage and disadvantage of quantum computing. Like the recent IBM first commercial quantum computing breakthrough and showcase, it has been shown in theory that a quantum computer will be able to perform any task that a classical computer can. And recent IBM showcase demonstrated it as well. However, this does not necessarily mean that a quantum computer will outperform a classical computer for all types of tasks. If we use our classical algorithms or quantum computer, it will simply perform the calculation in a similar manner to a classical computer. In order for quantum computer to show its superiority, it needs to use new what we call quantum algorithms, which can exploit the phenomenon of quantum parallelism. In other words, if just repeat the same algorithms, nothing much to be gained. The disadvantage is, first thing, its cost. Even IBM recent showcased their commercial quantum computing solution. It is make viable sense to offer as a subscription basis based on the use case on demand only. For quantum computing to be really achieve critical mass adaptation, it take a long time for all cost variable become reasonable. Then when we can see how quantum computing revolution the current mass technology, so it makes sense to be aware that it is coming but may not necessarily heavy invest it yet.